Today, I am going to show you a brand new technique mainly used for video extension. That means making your videos longer. It is worth mentioning that this extension method will not just lengthen your video. It will also extend your audio. Plus, the extended video handles the overall style and character consistency absolutely perfectly. At the same time, we are also going to provide you with a 3-stage upscaling method. This will easily turn your video into a 2K masterpiece, and the speed is incredibly fast. To fully demonstrate the powerful extension capabilities of this technology, let's look at the example below. This video is quite unique. It features a beautiful girl making funny faces, and the overall rhythm is much stronger. So compared to those traditional dancing videos, the difficulty of extending this one is much higher. Let's do a comparison. On the left is the original video, and on the right is the extended version. By comparing them, you can see that the extended video perfectly maintains the style of the original. And this style isn't just reflected in the visuals. The consistency in the audio is also maintained exceptionally well. So how exactly did we achieve all of this? Let's walk through it in detail to make the demonstration easier. I have also built this workflow on RunningHub. In the ComfyUI space, RunningHub is a fantastic online cloud platform because whenever new extensions or models drop, they are always the first to follow up. At the same time, RunningHub also provides an online community platform for ComfyUI creators. Here, you can find a ton of inspiration and smooth running workflows. Now, let's take a look at this workflow. The overall workflow is essentially an LTX 2.3 image to video workflow. The biggest innovation here is the latent generation. Of course, the latent we are talking about here includes both audio and video. There's a specific node in here called LTXV, Audio Video Masks. By using this node, we can easily extend our latent, thereby achieving the goal of video extension. First, I need to clarify that this node operates on the latent space, not on the pixel space. Why do I say that? Let's do a quick little test to help you deeply understand the latent space. We all know that after the pixel space is encoded by the VAE, it becomes a latent. In the latent space, images are usually much smaller. You can simply think of the latent as a compression of the pixel space. Everyone notices how the latent compresses video resolution. But many people overlook this question. If we encode a 121 frame video into a latent, is its size still 121 frames? Let's use this workflow to test it out. First, we load a video and we can get its size and frame length. What you are seeing right now is all data within the pixel space. Then we use the LTXV video encoder, which is the VAE to encode it. After encoding, we can also check the size of the latent. Did you notice? Besides the resolution, the actual frame length has also been compressed. How big is this compression ratio? It is basically around 8 times. So we can draw this conclusion. This compression doesn't just happen with resolution. It also happens with the total frame count. Through this experiment, it is not hard to see that operating within the latent space, whether for images or videos, will always be much simpler and highly efficient. Let's summarize the core functions of this node. Its main job is to precisely define the reference area and the generation area within the latent space. Moreover, it ensures that the audio and video are strictly synchronized on the timeline. How should we understand this? Let's give an example. Say you have a 3-second video and you want to extend it to 10 seconds. You need to tell this node 2 things. First, which parts of the video are for reference. Naturally, we mean the first 3 seconds. Second, which parts are newly generated. Since I want to extend it to 10 seconds, the latter 7 seconds will be newly generated. Next, let's look at its inputs. First, we have 2 latents, because it can extend both audio and video. There are 2 types of latent inputs. One is the video latent, and the other is the audio latent. There are 2 very crucial inputs here. One is called video start time, and the other is video end time. To explain this clearly, let's build a workflow and run a simple test for you. First, we uploaded a video. For the sake of this demo, we only grabbed 60 frames from the entire video. Then we encoded the audio and video through the VAE to get the data inside the latent. Pay attention here in the pixel space. We grabbed 60 frames, but in the latent space, it only has 8 frames. The 60 frames we pass in represent the reference video, and its length is roughly 2.5 seconds. We want this node to reference the 2.5 second video we provided and start generating new video from the 2.5 second mark. The total length of the reference video and the generated video is 10 seconds. Therefore, the remaining 7.5 seconds will be newly generated video. But the generation rule is that it must reference our previous 2.5 second video to generate. That is the meaning of these input fields. After passing through these nodes, the total frame count in the latent becomes 38. This indicates that we have successfully extended the data within the latent. There is also a very important concept here called the mask. This mask is not the black and white image we usually talk about. Instead, it is a special marker used to identify which frames in the entire latent are reference frames that must be output exactly as they are without modification, and which frames must be automatically generated by the model. Once you understand the basic usage of the LTXV audio-video mask node, parsing the entire workflow becomes pretty simple. All right, let's look at the first part, processing the original video. First, we need to scale the original video. In the configuration, we explicitly state that our target resolution is 960 by 1280, which is a 3:4 portrait video. So we first need to scale it down to half of our target resolution. Why scale it to half? Because later on, we are going to do a 2x upscale. This way, it will align perfectly with the original video. After processing the original video, we need to generate our reference frames. Generally speaking, the video we pass in will be quite long. If we use every single frame of the entire video as reference frames, that is just not realistic. So typically, we start from the last frame and extract a portion to serve as the reference frames. Here, I have set it to 73 frames. Using the exact same method, we need to grab the reference audio. At this point, we will use the trim audio node. Pay attention here. All the input fields for this node are based on time, but what we have set are frame counts. For example, if we want to take 73 frames as our reference video, we need to divide those 73 frames by the frame rate and convert that into time. This allows us to get our reference audio. Then, we encode both the audio and video using the VAE, which gives us our reference latent. Moving further down, we find the node I mentioned earlier, the LTXV audio-video mask. We can use this node to extend our latent. We need to use the reference video we just generated and calculate exactly what time the last frame of that reference video corresponds to. In this workflow, we plan to extend the video by 5 seconds. Therefore, you take the time corresponding to your last frame and add those 5 seconds to get the end time of the entire video. By doing this, we get the final sampled video and audio latent. Below that is our first sampling stage. Since the rest of the workflow is identical to the standard LTX 2.3 setup, we can jump straight into sampling. The video resolution here is 480 by 640, which is exactly half of our target resolution. Further down is a video upscale. We have used this multiple times in our previous LTX workflows as well. After this upscaling, we get a 960 by 1280 video. At this point, the resolution perfectly matches the resolution we initially set. Moving down again, I am going to introduce a new node to you. This node is also used for video upscaling, and it can effortlessly upscale a video by 2 times. We will use a special node called RTX Video Super Resolution. If you want to use this node, you need to install a specific extension released for ComfyUI. What you are seeing now is the GitHub page for this extension. The installation is actually quite simple, but there are a few requirements. First, your graphics card must be from the RTX series. Additionally, your graphics card drivers and CUDA should ideally be updated to the latest versions. Once these prerequisites are met, installation is a breeze. Using it is also very straightforward. First, we need to set the upscaling method. Then comes the upscaling multiplier. Generally, we choose a 2 times upscale. Finally, we need to set the quality requirement. In most cases, we will select Ultra, which is the highest quality. Then we just run it. you will find that this node runs incredibly fast. Ultimately, we will get a 2 times upscaled video. To make the final result of the video absolutely perfect, there is another little trick: how to seamlessly blend the newly generated video with the original video. Of course, the first thing that comes to mind is doing a hard cut splice. But pay attention, the video generated through sampling doesn't perfectly match the original video in terms of color. It tends to look a bit duller. If you want to fix this problem, there are actually 2 methods. The first method is that I can just use the entire video as the reference video. If you do that, the final generated result will have completely uniform colors throughout. The second method is that we need to optimize the splicing technique. You can't just use a direct hard splice. We need to use a much softer approach for blending. The first solution is simpler, but it consumes a massive amount of resources. Especially if our original video is very long, using all frames as reference frames is just not realistic. Therefore, we have to figure out how to use the second solution. At this point, we will use a node that we have frequently used in our previous workflows, image batch extend with overlap. As you can guess from the name, when it splices the videos together, there will be an overlapping section in the middle. This overlapping area is basically a buffer zone that we can manipulate. Let's look at the inputs for this node. First, we need to provide the original video and our newly generated video. Make sure you remember this. The original video and our newly generated video actually share 73 overlapping frames. Because of this, in the overlap option, we set the overlapping frame count to 73. Since the frames are overlapping, we can only keep one set. Do you want to keep the ones from the original video's end or the ones from our newly generated video's end? You can decide that for yourself. Another very important setting is how we handle these overlapping frames. Usually we select linear blend. This way, in the overlapping section, there will be a smooth transition, which makes the video look much better, just like what you are seeing right now. Although there are color variations between them, visually, we almost cannot detect it. This is because it uses those 73 frames to create a gradual fade, smoothly transitioning from the original video's color palette to the new video's colors. This gradient approach is much softer. After extensive testing, it is easy to see that whether it is for expanding audio effects or extending video visuals, this method is highly effective. However, you must keep in mind that since this extension mechanism essentially relies on reference-based generation, its constraint on the video isn't overwhelmingly strong. Additionally, the LTX model is naturally quite sensitive to prompts. So, if your prompt doesn't match your video well, it is very easy to end up with unwanted scene transitions or sudden video cuts. Just like the example I am showing you right now, one moment she is dancing and the next moment she just walks away, and the overall environment and background drastically change. Therefore, when you use this, you must be very careful, write your prompts properly. I still highly recommend using a prompt generator instead of handwriting them. Otherwise, you might not get the absolute best video results, though it won't cause any massive failures either. Alright, that is all for today. What are you waiting for? Go try it out yourself. Follow me to become someone who truly understands AI.